So in these problems, we're going to look at how to evaluate sigma notation when it's given to us. So the first thing we have to understand is just try to understand what's given. So we're given that the problem starts at 1 and goes to 14. So this 14 right here is the in value, okay? And then we're given the formula, and that formula is the formula for an, right? So an is equal to, the sequence is equal to this rule. And every time you see a sigma notation for arithmetic series, you're always going to use S of n is equal to n over 2 a1 plus an. And you may say, well, I don't know the first term or the last term. Why would I be using this formula? And the reason is since they gave you the formula, it's actually very easy to find what a1 and an are. To find a1, all you do is just plug 1 into the given rule, -5 plus 2 times 1. And so a of 1 is just -3. And I would just come over here and say, well, that's -3. And to find a of n, what I would do is I would find a of 14, right? So when I find a of 14, I just do that order of operations, so -5. Plus 2 times 14, which is -5 plus 28. So a of 14 is equal to 23. So I'll just come over here and put 23 here. And then I just go ahead and just use the formula. The formula is adding up 14 terms. And that equals 14 divided by 2, and then I use a parentheses. I have a1, which I found there, and I add that to an, which is 23. And so S of 14 is going to equal 7 times 20, which is 140. And so one of the things I think is really important to keep in perspective is the formula gave us that S of 14 was 140. But the actual question was to evaluate this sum. So the 140 actually belongs here. This gives us way more information. This is telling us that we're adding 1 to 14 terms of this sequence. And this just says we're adding 14 terms of something. So keep that in mind that this is actually a better, more ample notation version of what's going on. So the interesting thing is that when I look at this problem over here, I have the same situation, but notice that A1, right? A1 is actually the 20th term. This is always n or an, so an is always this thing. So let's just start by doing the same thing we did, which is we're going to be using the formula S of n is equal to n over 2 a1 plus an. I find that doing this helps students understand what the real question is, like, where are we really stuck? So I don't think we're stuck finding these two things. A1 in this case will be A20, meaning A1 means first term. It doesn't necessarily mean plug 1 in. It just means the first term that you're adding. And you may say to yourself, why would somebody want to start at term 20? Well, let's say we wanted to find all of the amount of money we made in the month of February. Maybe we code those in with a 2 in the front. So we want to find the 2's. And so 2.0 and 2.9, we want everything else in between there. And so you could see how adding something that's specific would become very important to us if we were trying to just find specific information. So a of 20, which is a of 1, is -55. Okay, and then we are going to add that to a of n. And again, no brainer, there's always n is this. So that'll be 29 is equal to 5 minus 3 times 29. And 3 times 29 is 87. So we have a of 29 is equal to 5 minus 87. So a29 is equal to -82. So I just put that right here, -82. And then I just drop everything else down, but I have a little bit of a problem with what n is. So n is the difference between these terms. And what's interesting about that, I want you to think about this just for a minute. How many terms are actually between 20 and 29 if you include 20? So many students, when they first see this, they say, oh, the difference between these two terms is 9 terms. But there's actually 10 terms here. And you may say, how is that possible? Well, think about this. If I asked you to add up the 10th and 11th term, how many terms are there? 10th term and 11th term. There are 2. What if I asked you to do the 10th and the 12th? 10th, 11th, and 12th? Well, that's 3, right? But if I subtract this, I get 2, but there's actually 3 things in the list. So the rule of thumb to figure this out is you take these 2 numbers and you subtract them normally, 29 minus 20, and you take that answer and you add 1. So there actually are 10 terms in this sequence that we're actually trying to add together. And so we're actually finding S of 10. Now you may say, well, that doesn't work over here. Let's see if it does. If I take these 2 terms and I subtract 14 minus 1, I actually get 13. But then if I use the rule, I add 1, and then I get 14, which is what we actually found right here. So it actually works every time. And the reason we're adding 1 is we're adding back in the fact that we're using the term at the bottom. We're using the 20th term. So there's actually 9 terms plus the original 20, and that gives us 10 terms. All right, so to figure this out, of course, we need to break it down a little bit here. So this will be 5 times. All right, so let's think about that for a minute. Add these together, I would have 7, and then carry the 1. So I would have negative 137. All right, so again, 2 and 5 make 7. And then I have 5 and 8, which are 13. So negative 137. And then I multiply those together, and I get that S of 10 is equal to negative 685. Okay, so that's what this series equals. Remember, this is the formula, but this series equals negative 685. Again, to keep that in mind, what we did is we started at A20, right? And we went all the way up to A29. We found all of those things with the formula and then added them all up. But all we really did was find the first and the last. And that's what's amazing about the formula S of n equals n over 2 a1 plus an.